All right, so we are going to construct similar triangles. And what's nice about this construction I want you guys to do is we're not going to limit ourselves to a specific scale factor like we did with the dilation. In this case, what we want to do is we basically want to just construct a triangle that's the exact same shape as this original ABC, just a bigger or smaller version of it, and I leave it up to you if you want to make it bigger, if you want to make it smaller. Because what I want you to practice here is basically angle-angle similarity. So how do we create this similar triangle? Well, what we are going to do is first just draw a segment here on the side. Doesn't matter if it's longer or shorter. If you make a longer segment, you could potentially end up with an enlargement. A shorter segment would probably get you a reduction. But really doesn't matter. You guys just kind of pick your length. So I'm going to go ahead and draw a segment here. I'm going to call it XY. And now once you have your segment, what you want to do is decide what XY is going to correspond to. Do you want this XY to be proportional to AC? Do you want it to be proportional to BC? Do you want it to be proportional to AB, right? It's up to you. I'm going to say I want XY to correspond to AC. So I'm basically going to take each of these angles, copy it on to X and Y to find my similar triangle. So now we have to dig into our memory and remember, well, how do we construct congruent angles? So the first thing you want to do is open up your compass. It doesn't matter how big or how small this setting is. The bigger it is, I think the easier it is to work with. The smaller it is, the less chance of your marks overlapping, so it's kind of up to you. But just open it up so it's big enough that you can create an arc with the point on A and your pencil going through both legs of that angle. So what we want to do is use that exact same setting and copy it over here onto X. Just like that. And then remember, the size of the angle is basically the size of the rotation. That's why we have to be on this exact same size circle. So what we want to do is we want to figure out how wide this angle is by measuring intersection using our compass. So take your compass, put the point on one intersection, open or close your pencil so it's on the second intersection. I'm going to be as precise as possible, so try to be accurate here. Lock in that setting, and then what we're going to do is copy it over. So on XY, I'm going to find the intersection here with the arc, put my compass point on there, use my pencil now to mark off a little X, and if I connect the vertex X to that intersection, I'm going to get the exact same angle as angle A, the exact same size angle. All right, there we go. So that should be the size of angle A. I'm going to make this, I made this nice and long because we just don't really know how long that third side is going to be until we've constructed that second angle. So make it nice and long so you have space to work with. And you can see why we need a second angle now, because if I connect Y to that ray anywhere, we don't necessarily end up with the exact same shape. But once we lock in angle C onto Y, then we're stuck, and then we do have similar shapes there. So that's why we have angle-angle similarity for the triangle. So we're going to start off the construction of the angle C, right? The congruent angle to angle C. The same way, open up your compass. Doesn't matter how big or how small this is. Put your compass point on C. Draw your arc. Being sure to not change your setting, we're going to repeat that here on Y, just like that. And then just like before, use your compass to measure the distance from intersection to intersection. So I'm going to go ahead and put my compass point here on the intersection and then open up my pencil so I'm touching the second intersection. That tells me how far I've moved along the circle. And now I'm going to put my compass point on the intersection of the second arc with XY. Swing it out to create the X. And now if I connect Y to that intersection, I should have an angle the exact same size as angle C. And then I should have a triangle similar to ABC. So there's my third point Z. So triangle XYZ should be similar to triangle ABC, or I should say XZY and ABC, because of angle-angle similarity, right? These are congruent and these are congruent. So that's how we can construct, in general, similar triangles.